Hello and welcome to this session where I will be introducing you to Eclipse JKube. My name is Marc Nuri. I'm a software engineer working at Red Hat, and I'm currently working on two open source projects, the Fabricate Kubernetes client and Eclipse JKube, which I will be introducing today. So in today's agenda, I will start talking about Cloud Native and Kubernetes. Then I will describe what Eclipse JKube is and what it can provide for you. And then I will showcase two demos using Eclipse JKube. Finally, I will talk about the future plans for the project and the roadmap. So let's start talking about cloud native. If we check the Cloud Native Computing Foundation definition, we see that cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. So this really is a very broad definition, and probably for us Java developers, what makes more sense is that the cloud native brings, it's basically a change of the paradigm. So we were used to a different architecture. Our applications were based on a monolithic architecture. And now that everything is cloud native, we have switched into a microservice architecture, a distributed computer architecture, which brings a set of new challenges. So now we have to deal with data consistency, security, service discovery, service communications, distributed logging, monitoring, fault tolerance, and a huge set of new challenges that previously were not there or were not as important as they are now. But it's not only that, we've changed the workflow for our development process. So right now, our applications are probably intended to be run in a cluster, which can be Kubernetes, OpenShift, or maybe another flavor of Kubernetes, which means that our applications need to be shipped in a different way. So now we need to ship the applications as container, as Docker images or container images. And this means that we need to create Docker files and create these Docker images. But not only this, so now in order to be able to deploy the application, we need to create these cluster configuration files and manifests. So we need to actually master what kind of resources the cluster is offering us. So we need to know about deployments, replica sets, pods, services, ingresses, configuration maps, etc. So it's a huge set of new concepts that we now need to know, understand, and master. And this was probably something that we didn't have to do before. So here is where JKube comes in handy, because it actually tries to abstract away and the implications and the implementation details of all of these kind of configurations and all of these additional tasks that we are needing to deal with. So what's Eclipse JKube? Eclipse JKube is a set of tools and plugins that will actually help you generate these container images and then generate these configuration manifests and actually apply them into the cluster. So JKube comes in as of now in three flavors, let's say. So we have this standalone Java API that we call Kit, and then we have two Maven plugins. So the first Maven plugin is the Kubernetes Maven plugin that basically uses this Kit in order to generate these images and these configuration files for Kubernetes, and it basically uses the standard Kubernetes resources. And then we offer this incremental OpenShift Maven plugin, which actually is built on top of the Kubernetes Maven plugin to offer more OpenShift specific. So it offers S2I build strategy for building images, and then it offers more specific OpenShift cluster resources such as build configurations, deployment configs, routes, etc. So regarding build strategies, as of now, we support the Docker build strategy. So in the case of the Kubernetes Maven plugin, this will require to have a local Docker daemon running in your system. Or in case of OpenShift, this will perform a Docker build, but in your cluster. Also for OpenShift, we are offering a source to image binary build strategy. In this case, the build will be running on your cluster. And finally, we offer a Jib build strategy. In this case, the build is delegated to Jib. So you actually don't need to have a Docker daemon running in your in your computer. And then JKube is based on a set of very strong opinionated defaults. So we are actually offering configuration defaults for many different frameworks and technologies, but this really should be enough for many of your applications, but probably it's not for some. So then we have this XML plugin configuration. So you can actually override these defaults in your Maven plugin configuration. Or then we also offer these resource fragments, which is also a very, very easy way in order to improve the cluster configuration manifest that we provide. So you can provide parts of these configurations, some small fragments that then will be merged into the actual fragments that were generated by JKube with its opinionated defaults. But coming back to that initial slide where we were talking about the new difficulties that come with this new developer workflow, what JKube also tries to aim is to simplify this workflow for you. So if in case of you are using a Maven project, you basically usually had to package your application and you were left with this jar or war package, but then you are faced with the challenge of actually putting this war or this application in your cloud. And here is when JKube comes really handy. So the first goal that we provide is the build goal. This build goal is in charge of generating probably your Docker file and then building your container image. This container image can then be pushed into a public or private registry in order for your cluster to be able to pull your image. And then we offer this resource goal. The resource goal is actually in charge of generating these configuration manifests. Once we have these YAML files, it's as simple as invoking the Maven KHS apply goal, and this manifest will be applied into your cluster. Again, without any kind of specific configuration from your side. It's everything should be actually inferred, the cluster configuration, etc. And then we offer a set of specific goals for developers. So the first goal is the KHS log. This will actually connect to your cluster and tail the logs for your application or your container running in the cloud. The debug goal, which will actually open a remote debug session with your application running in the cluster. And finally, the watch goal, which is in charge of hot reloading your application. So it will detect changes on your application and will actually hot reload your application in the cluster. So in this first demo, what I'm going to do is I'm going to showcase how you can actually deploy the Spring Boot pet clinic example application into an OpenShift cluster by using Eclipse JKube, but with actually not even configuring the plugin in your Maven project. So just by using the Maven goals with any kind of configuration. So I chose the Spring Boot pet clinic because it's a pretty well-known project. So the first step is we need to clone the project. And we build the project just as any other usual Java application. So we'll package the project in a Spring Boot jar file. And as I said, what I want to do is I want to deploy this application into an OpenShift cluster. So okay, the application was built. So let me change to my local OpenShift cluster. And now that the application is packaged, the first thing that we want is to actually build the application. So in this case, we are going to use the build goal. Since we are targeting an OpenShift Maven plugin, Eclipse JKube actually infers this cluster configuration and will perform an S2I build. So this build is going to be performed in the cluster. So if you check, as you can see, the build is actually running in our cluster right now. Okay, so the build is complete, and the next step is going to generate the cluster configuration manifests. This will actually analyze our project and check which kind of project it is, if it's a Spring Boot project or whatever, and will infer most of the configurations for us. So in this case, if we check the YAML configurations that JKube generated for us, we can actually see that it generated a service, it inferred the port where the application is running, it generated a deployment config. Again, since we are targeting an OpenShift cluster, it will generate OpenShift specific resources. And it's going to even add a liveness probe and a readiness probe for us. So this is all, as you saw, we didn't add any kind of configuration. We just cloned the project and it's everything in the raw. So it's detecting everything. So now that we have the resources built for us, it's a time for us to apply the resources. Again, if we go and check the pod, this is the pod that was used to perform our build. And now we should see that the deployment is coming up and that the pod has been deployed. Again, since we added this liveness and readiness probe, we can actually check when the container comes ready or not. So let's wait a second. Okay, so now the pod is ready, and since we were using the OpenShift Maven plugin, we could a route was generated for us, so we can check the route, and if everything was okay, we can see that the application is actually running. We can check everything. We see that the database is working well, and we could even add a new entry. So again, everything is working as expected. So yeah. So we just saw how we actually could deploy the Spring Boot Pet Clinic with not a single configuration, just by invoking 3 Maven commands. But it's not only this. We could actually debug the application. So in this case, we are going to use the debug goal. And this will actually redeploy the application, but with an environment variable that will load the application in debug mode. So our pods should be restarting. Okay, so when the new pod becomes ready, we should be able to debug the application. In order to debug, we simply need to create a standard remote debug application. The port is the 5005, which is the standard. So again, when this pod is ready, we should be able to connect. Okay, great. So we were able to connect to the debugger, and now we can actually check one of the controllers. So we are going to add a breakpoint into this veterinarian controller. So whenever we visit the veterinarian's list, our application to stop. Okay, we see that it stopped. We could now modify one of the values. So let's try this. Okay, so if we resume the application, okay, we can see that the value was modified inside the cluster. So this is actually awesome. Next. So one of the other goals intended for developers is the log. So this will actually connect to the application container and forward the logs and print them in our screen. So as you can see, we can see the standard log, and if you know a little bit the Spring Boot Pet Clinic, one of the links here is actually intended to perform like a fake exception. So if I press this link, something should be printed in the log. Let's check it. Yeah. So as you can see, whenever I press this link, a fake exception is thrown and it's actually printed in the log. So just to complete the demo, we can actually see the undeploy goal, which will actually clean up all of the resources that we generated in the cluster. So if I run this, all of these resources that were generated, the pods, the build, the route, you can see everything has been cleaned up. Pod is terminating, but as soon as it terminates, it should be gone away. Same for the builds. So yeah. Okay. So this concludes the first demo. Let me walk you through the second demo. In this second demo, what I'm going to do is just grab an old school Java web application and deploy it into a Minikube cluster. So let me get started. So the first thing, let me switch to Minikube. Okay. Okay. So let me show you the application. This is just an old web application. It has some dependencies because, well, this is an application that we run in a Wildfly web application container. So it provides some of the JBoss dependencies. They are provided. So this will be provided by the web application container. These are all the dependencies the project has. And then we added our plugin in the plugin section, and we configure the plugin in the properties. So we only provided two configurations, in this case, the Docker image name. So we are going to name our image like this. This is necessary for me to be able to push this into my Docker.io registry. So since my username is Marc Nuri, I need to change the image name. And I'm also providing this configuration for the service. So the generated service manifest will be of type noteport. This is good for Minikube because it's the easiest way to check if our service is running instead of creating an ingress and some additional resources. So it's just to simplify. Okay, so coming to the application, basically it has this beans configuration that is used for dependency injection, and some JBoss specific configuration. This is actually the file that JKube will detect and will be used to infer that it needs to be run. The application needs to be run in a Wildfire container. So then we have this index that basically will redirect the user to a servlet that I will describe now. So first place, we have this hello service. The hello service will simply greet the user, like saying hello and whatever we said here. And then we have this servlet that uses container managed dependency injection in order to inject this service. And then it will use this service to perform this greeting and print the greeting in the web page. So we can start by packaging the application. The application is built, and now we can use, since we are using the OpenShift Maven plugin, we use the KHS prefix, and we can build the application just as we did in the other example. But now, since we are using the Kubernetes cluster and we are not using OpenShift, it will perform a Docker build. So it's going to use my local Docker daemon. So if I check my images here, I can see that the image has just been generated. So again, another of the challenges would be to push this image into my Docker registry. So I'm going to use this push goal that we provide. And if everything goes well, okay, the application has been pushed. If I check my registry here, okay, 1 second. Yeah, it was just pushed a few seconds ago. So now is the time to actually deploy this into my local Kubernetes Minikube cluster. So I'm going to generate the resources just as we did before, and I'm going to also apply these resources in just the same run. So basically, first we're generating the resources. These are Kubernetes specific resources. They don't add this route or OpenShift specific stuff. And now they've been applied. So if I check my running pods, I see that the pod is running and started, and I should be able to check this web application. Okay, so yeah, it's running. And it's running. Okay, so just as we did before, we can check the logs of the application running in the cluster. Yeah, so the logs are tailing now, and we can see that the application is running inside a Wildfly application container instead of just a Java runtime. In the previous example, the application was running on the standalone Spring Boot generated jar, and now it's actually a war deployed in the Wildfly web application container. So just as before, we are going to clean up the cluster. A typo, sorry. Okay. Okay, so if we check the pods, we see it's terminating and everything is clear. We get the deployments. Yeah, no resources found. This concludes the second demo. So let's move on. Future plans for Eclipse JKube. So let's see what's coming in the next days or in the next months. What we actually want to do is include more build strategies, namely Canico, but any other thing that suggests that it's good. And we also want to create Gradle plugins on top of this Maven plugin. So right now we're only supporting Maven projects, but our intention is to support Gradle projects too. And finally, provide support for more frameworks and more opinionated defaults and so on. So the most important thing is that what we want is that the community to get involved. So it would be nice if you actually got in touch with us and provided feedback and said, hey, I would like to see this new feature in the project or whatever. So that's what we are really striving for in the next few months. So thank you very much again for joining the session. I hope that you enjoyed it. You can find us on Twitter, or you can visit the repo, or you can even visit our website where you have more information about how to get involved, how to contribute to the project. So again, thank you very much, and let's see if you have any questions in the next Q&A session. Thank you. Bye. Okay, so let's see if you have any questions. First one, will the flow be the same for OpenShift 4? Yes, exactly the same. We do support OpenShift 4. You can try it yourself, but everything we did in today's demo should actually work in OpenShift 4, same as it did in OpenShift 3. Will JKube be integrated to Quarkus? So Quarkus offers its own extensions to do more or less what you saw. It has a Docker extension, a Jeep extension, a Kubernetes extension. So there are already certain alternatives that you can use using the Quarkus way, but obviously JKube provides a more integrated and configurable way to do the same. You can actually use our plugin with Quarkus and with any Quarkus project, and it will work exactly as we did with the Spring project and with the Wildfly project. So you can try also the Quarkus way and see if which way you prefer. Also, is Gradle support planned? Well, this was already in one of the roadmap slides. Yes, we actually planned this for the 1.1 milestone, and we'll try to implement this as soon as possible, since there is lots of people interested. Okay, what are the required dependencies? OC, kube control, etc. So we don't rely on OC or kubectl. Internally, JKube uses the Fabricate Kubernetes client, which our team also maintains. So there's actually no dependency to binaries, except maybe for Docker in case you're using Docker builds, but even this can be substituted with Jeep. So you really don't need any specific binaries or dependencies in your environment to run JKube plugins. And finally, will Fabricate Kubernetes client be moved to JKube? Not that I know of. So it's an independent project that it has its own community. We are trying to build a similar community with JKube, and what we are looking forward to is that people actually get involved in the roadmap and also help us decide on what are the next features and I don't know, things to implement in the project. And I think this is these are all the questions. I don't know if there's something else. If not, thank you very much, all of you, for joining and for getting to know JKube. I hope to see you around in the project, maybe reporting some issues or preferably some pull requests to help us. So thank you very much. Bye.